This video will focus on the team role of sketcher. For information on other team roles such as point and instrument, look for other videos I've produced that cover the details of those team roles. To sketch efficiently, it's good to have a regular workflow that you use for each survey shot. In general, these tasks will include recording the data, drawing a line plot, and then sketching the details of the cave passage. In most cave surveys, the role of sketcher is the most demanding and time-consuming. As a result, the sketcher generally sets the pace for the entire team, and often, by default, acts as the trip leader by directing when and where to begin and end the survey, when to take breaks, and instructing the team on what data is collected and how it should be communicated. There are many types of sketchbooks available, but for large rooms or very large passage, sometimes larger paper and a folding clipboard work well. Some people use bound books, but since the pages aren't easily removed, original sketch notes end up going back into the cave multiple times, and there's an increased risk that the whole book might get lost or destroyed. It's also much more difficult to scan the notes from a bound book. Some basic equipment you'll want to have for sketching include a pouch for carrying the survey book and pencils. You'll want to use a mechanical pencil and have at least one backup. Additionally, you'll want a protractor for drawing line plots. I prefer loose leaf pages in a ring binder. Sketches can be more easily scanned and archived following each survey trip, and the number of pages brought can be customized to the length of trip. The standard used by most cavers is the yellow plastic Write in the Rain 6-ring, half-inch thick binder, which is designed to be used with their 4.6 by 7-inch pages. Write in the Rain paper is a good choice for most cave surveys because it is water resistant, so it holds up well in high humidity or from incidental contact with mud or water, though it's not entirely waterproof. So with every survey you should include a title page. Some of the most critical information will be the name of the cave, the date of the survey, which would be used later to calculate things like declination, the area that you're working in the cave, especially for larger caves, in case there's duplicated survey stations in different areas of the cave. You want to include the names of the people involved in the survey trip, so who the sketcher is, who's on instruments, and who's doing point, and any other duties, things like inventory, or if there's somebody taking photos, include their names on there. Other good information to include on a title page would be things like what instruments are being used, and if they've been calibrated, what maybe some of the calibration parameters were, what time the survey trip began and ended, so they're in caves where they keep track of volunteer hours, you have more information on the total length of the trip. It's good to record on the cover page, on the title page, things like the survey stations that were used during that survey and what the tie-in stations were. This makes it easier for the cartographer later to identify the survey notes and what surveys they're associated with. And then there's also a place on this title page anyway to show what the total survey length and number of shots were, and I break it down into new survey, resurvey, and redundant survey, and then a total down at the bottom. And again, this is something that can be used by the cartographer or for cave managers to keep track of the length of the cave. After the title page, all the other pages will either be data pages or sketch pages. The data pages are made up of a table for recording survey designations and then survey data. And then the sketch page will basically be a graph or grid paper. These can be either imperial or metric. This one here is in inches, but you can have these in centimeters as well. Some basic information that should be on all the data and sketch pages are the date of the survey, the name of the cave, and the name of the sketcher. So that should be on all of these pages, and that's in case pages come out of the book and for some reason get separated, they can be reunited with the right survey book later. Another thing that should be on every survey page is the page number, and pages should be numbered sequentially, 1 through however many pages are needed, and then at the end of the survey you put the total number of pages. So if this is the second page, this would be page 2 of, and let's say for example there's 10 total pages, this would be page 2 of 10, the next page would be page 3 of 10, and so on. This allows you to Make sure that you aren't missing any pages, and that if a page, like in the case of this paper, it's loose leaf paper, so if this gets separated from the book, by numbering the pages you can get them back into the right order, into the right survey. Some additional information that's important to have on sketch pages is an indication of what direction is magnetic north. Almost all sketches will be drawn with magnetic north as a reference, and the most common is to have magnetic north to the top of the page, but sometimes it could be to, say, the left side of the page. You also want to indicate what the scale is for the sketch, and I'll go into details about how to use scale later, but in this case, this grid paper is in inches, and so there's a pre-drawn box here to show that 1 inch is equal to however many feet you want to use for your scale, but that needs to be indicated so that the cartographer knows how to scale the sketch to make it fit with the line plot. This template also has a place to indicate whether the sketch is a plan view, which is a top-down view, or profile view, which is a side view. And some people will put plan and profile on the same page. I generally will put plan on one page and profile on another page, so as not to confuse them. The scale is the ratio of the distance used on the sketch page compared to that same distance in the real world. The scale might be expressed as an equivalence of units, such as 1 inch equals 20 feet. The first value in the scale should be the distance on the page, and the second value is the distance in the real world. Scale can also be represented as a ratio, such as 1 to 240 or 1 to 600. The scale should be a balance such that a reasonable number of survey shots will fit on a page, while still being able to include a sufficient amount of detail. For imperial units, typical scales range from 1 to 240, which is the same as 1 inch equals 20 feet, on the large end, to 1 to 600, which is the same as 1 inch equals 50 feet on the small end. The most common scale in the U.S. for drafting finished maps is 1 to 600, so sketches shouldn't be made at a scale smaller than this. A larger scale is typically used for smaller passage requiring shorter shots, and a smaller scale is often used when sketching especially large passages or rooms. The most common metric scales are 1 to 250, or 2 centimeters equal to 5 meters for smaller passage, and 1 to 500, or 2 centimeters is equal to 10 meters for large passage. Sketchers should consult with the cave's cartographer to determine what might be appropriate scales for a given cave. Quality sketches are the foundation for a quality cave map, and generating sketches that are drawn to scale is a fundamental part of the accuracy of a survey. Sketching to scale simply means that the line plot is drawn such that each shot is in the correct orientation relative to magnetic north, and the length of each shot is in the correct proportion according to the scale being used. It also generally means that the walls, ledges, rocks, and other passage details are in the correct location with respect to the survey stations, and they are drawn in the correct relative proportions. The line plot is the scaled graphical representation of the survey shots and provides the framework around which the rest of the passage information is sketched. The most accurate way to draw the line plot, assuming it isn't being drawn for you by a digital device, is to use a protractor. There are many varieties available, and they all work well enough, but they are all more accurate than any other method, such as determining delta x and delta y of a shot and counting the boxes on your graph paper. One of the more popular protractors is the cave compass, which is a design derived from a Silva-style baseplate compass. When survey shots have a steep vertical angle, then their length, when viewed from above, appears to be shorter than the full distance between the stations. The horizontal component of a survey shot is the cosine of the vertical angle multiplied by the shot length. As a general rule of thumb, shots with inclinometer readings between 0 and 20 degrees don't need to be adjusted. At 20 degrees, the horizontal component of the shot is 94% of its full length, and the small 6% reduction in length is small enough that it can generally be ignored. For steeper angle shots, it is a good idea to reduce the effective shot length in the sketch to maintain the correct plan view proportions. Some protractors have tables that give shortened lengths as a function of the total shot distance and vertical angle. A table such as this can also be printed and taped into the inside of a survey book for reference. Another option is to apply an approximate multiplier based on the shot angle, and remember the multiplier. There are standard symbols that are used to represent specific features in caves. These symbols are used to show floor and ceiling ledges, water features, slopes, speleothems, floor detail, and human artifacts. It's a good idea to create a Symbology cheat sheet and put it in the back of your sketchbook for reference. This can be very useful for less experienced sketchers, but as you gain practice, you'll probably find yourself referring to the sheet less and less. If you encounter a feature that isn't on your sheet, and you can't remember the symbol, you can make up your own, as long as you also put a legend on the sketch page explaining what the symbols represent. If a profile view sketch is also going to be captured, it is usually included on a separate page from the plan view. There are different types of profile views depending on the way the data is projected onto the page. For in-case sketches, the standard is an extended profile, where the shots are drawn without any shortening of the length to account for the direction of the shot. Essentially, this takes any bends out of the passage and stretches things out as if the cave were one long straight passage. This simplifies the sketching process, but creates a little work for the cartographer to deal with later during the drafting phase. In caves with many steep angle shots above 20 degrees, the profile view line plot can be used to determine the horizontal projected length of each shot without the need for trigonometry. In this case, the sketcher would begin by drawing the line plot for the profile view, then using the horizontal length, next sketch the plan view line plot. So I'm going to walk you through an example workflow for drawing a sketch, and I'm going to use actual survey data from a local cave here in Colorado. First thing you do is fill out the page numbers. In this case, this is going to be page number 2, or page number 1 is our title page, and then the first sketch page will be page 3. Again, on each page you want to fill out the date. This was a survey that was July 2nd, 2017. So as the instrument person reads off numbers, in this case we're using an RTB survey. RTB 11 to RTB 12 was the first shot. You record the distance, and as they read you the number, you repeat it back to them for accuracy. The front sight azimuth was 346.2, and the front sight inclination was minus 1.4. The back sight numbers are what we call corrected numbers, so they're 180 plus or minus the actual reading, and so this was 348.0. And we do this, I prefer to use corrected back sights because it allows you to compare and make sure that they're within tolerance with less likelihood of error due to doing the math wrong in your head. In this case, we're 1.8 degrees, which is kind of on the high side, but our tolerance for front sights and back sights in this cave is 2 degrees, so that's within the tolerance. So we accept that number. Backside inclination was minus 1.5. Again, this is a corrected number, so the actual reading would have been plus 1.5, but we correct it for the back sight so we can compare more easily. Left, right, up and down numbers in feet were 1, 3, 1, and 2, so not very large passage at the from station, from station RTB 11. At RTB 12 we had 7, 1, 1, 1. Before you start sketching, you want to fill out what direction is north. You can draw a north arrow on the page. This one has one pre-printed, and then you just have to circle which direction is magnetic north. Fill out the scale. In this case, it's 1 inch equals 20 feet. And then whether it's plan or profile sketch, in this case we're going to do plan sketch, and then I'll show you how to do profile. So for this first shot, it's 40 feet long, and we're at 20 feet to the inch. So the shot will be 2 inches long. And when you have a scale like 20 feet to the inch, this grid is in, the large boxes in the grid are 1 inch by 1 inch, and then it's broken into tenths. So each small box is 2 feet by 2 feet. And then the same thing with the cave compass here. It's broken into inches and then tenths of an inch. And so it should match up exactly with the grid on the paper. So to draw this first line, 40 feet long at a bearing of 346, we dial in 346 on the dial here. So that's nearly north, a little west of north, and so we dial in until we get 346 on the compass. We then want to lay it down on the grid and align these lines on the dial with align them with the grid on the paper. Now in this case, the cave passage is trending to the northwest, So the passage is going in this direction, and so we want to start on an area of the page that allows us enough room to draw and do the next several survey shots. So we're going to start in the bottom right-hand corner, in other words, the southeast corner, since the passage is going northwest. So what we do is take the cave compass, line it up with the grid on the paper, and then we look for a starting point. I'm going to use this 3-inch mark here, if you can see that. So we could just mark a station, and we use a small I use a small triangle to mark stations. And then you align that mark on the ruler, and then turn the cave compass until it's aligned with the grid on the paper, and then sort of push it down to hold it in place. Now again, the shot length is 40 feet, which corresponds to 2 inches. And so 2 inches is from here to here. And so you can then trace along the paper. That's your scaled shot length at the right orientation, 346 degrees. And at the end of that line, put another small triangle to indicate that next station. And you can go ahead and label the stations. This is RTB 11. And you want to allow enough room so that the station label doesn't overlap with the page. But in this case, at this station, it's 7 feet to the left and 1 foot to the right. So if we label it over here to the right, this is RTB 12. That won't get in the way of the cave passage. For this shot, the inclination is 1.5 degrees roughly. That's well below 20 degrees, and so there's no need to shorten the length of the shot for the vertical angle. So we draw that plan view shot to the full length of the survey shot, in other words 40 feet. The next thing I do is use the left and right values. So we have 1 foot to the left and 3 feet to the right, and I sort of put tick marks where the walls would be. So 1 foot to the left is about half a block. Again, these blocks are 2 feet by 2 feet, so about half a block to the left, and then a block and a half to the right would be 3 feet. So roughly there and there, that's where the walls are relative to that station. I do the same thing for the next station. So 7 feet to the left, and if it gets to be, if it's off at an angle where it's hard to count blocks, you can use your cave compass. So each one of these is 2 feet, so that's 2, 4, 6, 7 feet would be about here. And then again, 1 foot to the right of the station is fairly easy to estimate, is about there. So here's again where your left and right walls would be, left and right walls for this station. The next step I generally take is to draw the walls between the stations. If it's a particularly long shot, in this case it's 40 feet, that's a fairly long shot. If you can't see clearly the shape and dimensions of the cave passage walls between the stations, then you may need to walk to the next station before you can fully sketch it. But if you can look ahead and tell where there's any twists or turns in the cave passage wall, you can go ahead and sketch it. In this case, this passage is fairly uniform. There's a little bit of undulation in the walls, but there's no major turns in the passage, and so we can sort of sketch the walls in. We can sketch the walls in relative to where our tick marks are. Once we have the walls drawn in, we can start to draw other details. Normally, I would draw floor ledges and ceiling ledges next, and then maybe large breakdown blocks. In this case, this passage is basically gravel floored stream passage. There's no floor or ceiling ledges. There's really no speleothems, and there isn't any large breakdown. So I'm going to draw the stream, the water flow through the passage, basically use sort of squiggly lines to represent water flow with an arrow to point the direction of that water flow. And we have water flowing throughout the length of this survey shot. And then the floor itself, we want to, usually like the last thing I'll do is put in things like slopes and floor detail. In this case, it's a cobblestone floor, so draw in some cobbles to represent. So now we have a completed plan view of this survey shot. We can add other things, like we can add ceiling heights if we want. In this case, we're going from 3 feet at this station to 2 feet high at this station. In between, it's roughly 3 feet. We can include a ceiling height. We can include a cross-section if we want. We can do the cross-section at the station. It's usually easier to do it at the station because that's where you're stopping to catch up on your sketch. But you can do it in between the stations wherever you think the cross-section is going to be most representative of the shape of the passage. We're going to hold off for now. So let's move on to the next shot. RTB 12 to 13 was 25.4 feet. And so we'll go ahead and sketch this shot. We're at 294 degrees azimuth. So we take our cave compass and dial in roughly 294. Go ahead and line that up. Again, I use one of the inch index marks to line it up with the previous to line it up with the from station, and then align the lines here on the dial with the grid on the paper, and then hold it down. So this is 25 feet. So 1 inch is 20 feet, and then each of these is another 2 feet. So we're going 20, 22, 24, 25 is right about here. And then we draw that line. Put a station marker, and that's our next scaled survey shot. For this shot, there's a floor ledge that this station RTB 14 is sitting on, and that floor ledge is about 2 to 3 feet wide, and it extends down the passage more or less parallel to the shot, and it gets narrower as it approaches RTB 13, and it sort of merges with the wall, the left-hand wall here. So we're going to go ahead and do that floor ledge first, sort of in that shape. And then we put little hatcher marks to indicate what direction the floor ledge is facing. The top surface of that floor ledge is limestone, so it's bedrock. We use a bedrock symbol. And then the right-hand side of the passage to the right of that ledge is again cobblestone with water flowing through it. So we're going to use our squiggly lines and then go ahead and draw in cobbles for the floor detail as the last step. At this point, we want to maybe include a cross section. We haven't done that for a little while, and maybe we'll do it here where the ledge is. And so we want to include leader lines. That shows you the position of the cross section. In most cases, you'll draw a cross-section facing in the direction of the survey, so that would be sort of up and to the left here. And so we're going to draw the cross-section over here, give us a little space, and then on the opposite side, we want to use a little L-shaped line to indicate the direction. This is basically represents an arrow. You can actually use an arrowhead if you want, but that's sort of implied. And then for the cross section, we want to make it roughly the width of the passage, so it's about 4 to 5 feet wide here. It's about yay wide. There's a floor ledge on the left-hand side that's about 3 feet high. And then the walls kind of come up, and it's a fairly simple cross-section view. And then you've got some cobblestones on this side. There's bedrock there. If you want to show the stratigraphy, you can, in this case, we have horizontal bedding, and you can show that. Use the limestone symbol. And there you have a cross section. That's what it looks like as you're looking down the passage. Roughly 5 feet high, 4 feet wide. So we use the same set of data that we just generated to draw an extended profile view shot. So we're going to start with a clean sketch page, and make sure again that we record the scale. This is going to be 1 inch equals 20 feet, and in this case it'll be a profile view shot. And I find it a little easier to do profile shots in landscape view like this, rather than draw the profile view relative to north. It's going to be relative to which direction is up. So in this case, we're going to have up at the top of the page, and we go ahead and indicate that here. Again, you could draw a separate arrow to indicate what direction, but the reference for profile views is up versus down, not north versus south. So on this protractor, the cave compass, there's a separate set of numbers on the inside of the dial here. It goes from 0 to plus 90, 0 to minus 90, and this is used for drawing vertical angle shots or profile view shots. The numbers here are designed for drawing profile views starting from the left side of the page and moving to the right side of the page. And you would line that up with the vertical angle here, so plus 1.5 is about there. Then, similar to the plan view shots, you align these vertical lines on the dial here with the lines in the grid. And you would start with kind of an index mark here. So again, we can use a little triangle to mark our starting station, and then turn the cave compass till it lines up with the grid in the back. And then this is a 40-foot shot, so that comes out here to 2 inches. And draw another station marker at the end. So for sketching, we're going to draw the ceiling and floor rather than the right and left walls, and we can use the up and down measurements from our LRUDs to give us an indication of where where the ceiling and floor is. So for that first station, up was 1 and down was 2, so about half a block is where the ceiling is, and a full block down is where the floor is for that first station. Again, this is RTB 11. At RTB 12, up and down are 1 and 1, so here and here. And then just like you would sketch the walls, you sketch the ceiling. If there's any alcoves or domes, you would draw those in. In this case, it's a pretty uniform ceiling. It follows a bedding plane. And then with the floor, this is a cobblestone floor with water flowing, and so we can just draw in the floor detail. This next shot was 25 feet, basically 0 inclination. You don't really need to dial in 0, you can just follow the grid lines on the paper. I'm going to show you some examples of finished profile view sketches. This is the data we were just drafting, so from RTB 11 to 12 to 13 to 14, and then you can see the floor drops away and water starts to flow across bedrock in this case. And then as we get to 14, 15, 16, we get some steeper angle shots. And this is where you can use the profile view line plot to shorten the length of plan view shots without using adjustment tables or multipliers. So like for 14 to 15, you can come in here and, the shot length is this, you can figure out what the horizontal distance is and then use that in your plan view shot. So in profile view sketches, you want to include things like if there's water on the floor, what the floor detail is. In this case, it's bedrock through here. There's some pools. Here is a natural bridge, so there's bedrock sort of dividing the passage to an upper and lower section, and the survey goes below that. Here's some more examples of profile view shots. This is a later part of the survey, an RTC survey, and again there's bedrock, natural bridge, and so showing the line plot. Here there's some breakdown or rocks on the floor, larger breakdown, and then some speleothems. In this case, there's some soda straws and stalactites that are drawn in on the ceiling. And with any sketch, whether it's profile or plan view, as you sketch along, you start on one side of the page, and in this case, we're going from left to right. When you reach the edge of the page, if you have room on elsewhere on the page, you can start again. So in this case, we've gone from station 3 to 4. And then we start over here again with 4, 5, 6, 7, 8, and so on. You want to get as much sketch on the page as possible just for efficiency. Here's an example of a plan view sketch where we started here on the page, station 7, and as we surveyed along, when we reached the edge of the page here at station 12, we start again over here at station 12, 13, 14, until we get to the edge of the page. At this point, we've used up most of the page, and we then start on a fresh page. Here's an example plan view sketch that shows some other things to keep in mind. This is a relatively large room that has some alcoves and continuing passages off of different sides of the room. So as we surveyed into the room, we set a station in the middle, and then we did some splay shots out to where leads leave the room and different sides. And then in this passage here, the passage continued, so as we split off, we decided to survey into this room, and we mark this as a lead, generally use a question mark to mark that. Some other examples of symbols that are used here, again, floor ledges are shown here. Here's the symbol for ceiling ledge. There's a change in ceiling height here. There's some steep slopes here, so that we use sort of a chicken foot type pattern to indicate slopes in the direction of that slope. This room also has a fair amount of flowstone, and that's indicated here by these scallop marks. Again, this is a symbol that's used for flowstone, and it shows the direction from uphill to downhill. There's some large breakdown in here that's drawn to the right shape and size of the actual breakdown in the room. And then the rest is filled in with floor detail, things like sediment and cobblestones. In especially large passage or rooms, like in the example of this survey, we have several shots that are over 40 feet. There's even shots that are 50 to 60 feet long, and accuracy becomes an issue where you're trying to draw features, ledges, rocks, whatever it might be, in the correct position. And the survey will go through here, and this is actually sketched at 40 feet to the inch, so the passage here is 40 feet wide or so, and up to 20, 30 feet wide in other areas. So most people can make accurate estimates if you're within, say, 20 or 30 feet, but as you get to further distances, it gets to be a little more difficult to estimate the distances to objects accurately. So if you have a disto, or even better, a disto X, and you're at a survey station like here, you can take shots, sort of splay shots, even if you don't record the data, and get accurate distances, say to a wall or to a feature. And if you have a disto X, you can get the bearing as well, so that you can draw in things like this little alcove here. You can draw in at the correct location in the cave passage. You can do the same thing with rocks or ledges. And what I like to do with especially long shots is sometimes just do splay shots down the passage to, say, a rock. So I know the distance to that rock, and then I'll draw that in, and that becomes an intermediate landmark. And then I can draw things around that rock within 20 or 30 feet and have a little bit better accuracy on sort of triangulating where those objects are in the passage. Some people prefer sketching with fiberglass tape, and one of the strategies for longer shots is to lay the tape down on the floor and leave it in place while the sketcher moves through from one station to the next. And they can refer to the tape for reference, and again, this helps them with accuracy of locating ledges or rocks or other features in the passage. The best way to learn how to sketch is simply to start doing it. Pick a small and simple cave without too much complexity and begin surveying. If you pick a simple cave without a lot of complexity, that allows you to go in and not worry about the amount of time that's being spent on the sketch, and you can focus on producing good quality sketch. And as you gain experience, you'll naturally get faster and faster and more efficient, so you can generate high quality sketches and do it relatively quickly. There are no secrets or shortcuts to getting good at sketching. You just need to do it frequently. So look for opportunities in local projects and get out there and sketch as much as possible. Look at what other people are doing, and if you know other cavers that are efficient and generate good quality sketches, emulate their practices and ask them for tips and suggestions, and solicit feedback on your sketches. Thanks for watching. If you enjoyed this video, then please click the like button. Subscribe if you aren't already, so you can learn about other videos on the subject of caving, and comment below to let me know how I'm doing or to suggest other caving related topics.